This video is about isolating variables. I'm going to show you everything you need to know to isolate a variable, give you a couple of examples, and then in a separate video I will give you some additional examples plus a few that you can do. Now to start with, let me talk about something I saw a number of students make this mistake on a test, so I just want to address it. Let's say you had some variables represented by this, a times b over c. And there was great confusion with some students as to how you went about putting that a as part of the numerator. Well, let's say that I replace that with this. I just put parentheses around it because that will make it a little more clear in a second. And instead of writing that a there, I wrote it as a over 1, which we all acknowledge is the exact same thing. Now I have two fractions, and they are being multiplied by each other. And whenever you do that, you multiply the numerators, and then you multiply the denominators. So when I do, the numerators become a times b, and the denominators become 1 over c. So it simplifies to that. Now what the takeaway is that I took this a that was listed beside the fraction and being multiplied by it, and I just at will move the a up on top. It's because it is mathematically equivalent. The reason some students had difficulty with this is there was a naming scheme that we taught you way back somewhere, 3rd, 4th grade somewhere, that is kind of unfortunate. It looks like this. Right here, you would say that's 2 3/8. Well, what you really mean is it's 2 plus 3/8. You said and, that really means plus. Let's say they were inches. 2 inches plus 3/8 of an inch. But compared to this, you would think this is saying 2 times 3 over 8, and indeed it isn't. So because of this unfortunate choice when you were younger, it makes this a little confusing. Just remember, when they're being multiplied by each other, you can at will move them on top. That's not true when fractions are being added. Let me give you an example of one of the places where we use it a lot. This formula here explains how gravity works. And you see this g? We normally write this g by itself. For no good reason. These others are mathematically equivalent. The reason we do is because this m1 times m2 over r squared, there's something kind of pretty about that, something geometrical about that, and I could give you a big, long, and probably boring story about why it's beautiful for it to be written that way, but I'm not going to worry about that right now. Just know that I usually write it this way. But if you want to write it this way, that way, there is nothing wrong with that. And quite frankly, you can also write it where you have this and you just move the m to be the whole number being multiplied by it. There's actually some instances where this last rendition of it makes a little more sense based on the kind of problem you're trying to solve. So all that said, each of those is completely mathematically equivalent, so we can interchange them. Okay, let's get on to the rules of how you isolate a variable. Here in the box on the left, I have the order in which we should take care of isolating our variable. You will notice that it is not order of operations, it's order of operations in reverse order. Please excuse my dear Aunt Sally, is the order you do order of operations. Well, isolating for the variable is kind of essentially undoing order of operations. So you do it in the reverse order. So rather than walk you through each of these, let's put a formula up here, and we will isolate for one of the variables. Here would be a good one that I have handy. We're going to isolate for delta t so that we can keep track of what we're doing. I went ahead and wrote it in red. Okay, first step is the variable in question. Is there anything being subtracted from it? And the answer is no. Now there's some addition, subtraction stuff going on inside this parenthesis, but I can't see inside parentheses until I've got rid of everything outside the parentheses. That's a rule. That's an important rule. You can't see what's going on inside parentheses until you've taken care of everything outside the parentheses. As a matter of fact, that's why one of our order operations is parentheses here. All I know is I got some parentheses and they're being multiplied by delta t, so I don't have to worry about subtraction. What about addition? same deal. Don't know, can't see what's going on inside the parentheses. There's nothing being added to the delta t, so I move on to division. Yes, there is something being divided. Delta t is being divided by this 1/2, well, divided by 2 rather. And so to get rid of it, you must do the opposite. It's being divided by 2, so I must multiply it by 2. So that would take this form. Multiplying by 2 on the right makes the 1/2 go away. 2 times 1/2 is 1. And doing so on the left gives me 2 times delta d. I could put parentheses around these, but it really is not necessary. Okay, so much for division. What about multiplication? Yes, all this junk in the parentheses is being multiplied by the variable we're trying to isolate, delta t. Perhaps it would have been better if I'd said delta t is being multiplied by all this junk in the parentheses. So to get rid of it, you divide both sides by everything in the parentheses. It goes away on the left. You're left with just delta t. And on the right, you have 2 delta d divided by all that stuff. Okay, I now have delta t by itself, which is what I wanted all along, and so I'm done. I don't even have to take these last 2 steps. Well, that was pretty easy. Let's pick one that's maybe a little less easy and see that the same rules apply. We're going to take this same formula, but this time we're going to isolate for v sub s. Here's that same equation, but this time we're isolating for v sub s, and so I wrote it in red to help us keep track, but I highlighted the entire parentheses in blue because, as I've said, you can't do anything inside the parentheses till you take care of the stuff outside the parentheses. And that's one of our order of operations, or our undo order of operations, if you will. So let's just run through them in order and kind of see where we land. First thing is subtraction. The variable in question, again, I can't see it, so let me say the parentheses that contain the variable in question. Is anything being subtracted from it? No, there's some things being multiplied and divided by it, but not subtracted, so I can check that off my list. What about addition? Same story. The parentheses that contain the variable that we're trying to isolate does not have anything being added to it, so I move on to the next step, division, and here, yes, we do have something being divided by the parentheses that contain the variable we're trying to isolate. Those parentheses are being multiplied by 1/2. You could say that's divided by 2. So to undo that, we do its reciprocal. Multiplied by 1/2, we then, or divided by 2, let me say, we then multiply by 2. The left side becomes 2 times delta d. Could have put parentheses around that, but really don't need to. And on the right side, the 1/2 times the 2 we multiplied it by makes it go away. So we're left with just this. And we're done with that step, the division step. Now what about the multiplication step? Well, yes, the parentheses that contain the variable that we're trying to isolate is being multiplied by delta t. To get rid of it, I divide by delta t, and I get this on both sides. 2 delta d over delta t on the left, and then it was all this stuff in parentheses, all of that times delta t over delta t. The delta t's canceled in the numerator and denominator, and we're left with just this. Okay, next step is exponents and square roots. I will explain in the next video why exponents and square roots are the same thing. Now, some of you students might say, well, yeah, the variable in question it has a square there, but I would argue, I don't know, I can't see it. It's still inside the parentheses, which means it should, oops, there, look like that. Now, where we could have done something here is if outside the parentheses there was some kind of exponentiation there. That you would take care of, and then you would get down to the parentheses, but it's not that way, so let me get rid of it. So the upshot of it all, exponentiation, there's nothing to do, so we move on to the next step, which is parentheses. Since there's no longer anything going on outside the parentheses, then they just dissolve. Their only job is to insulate the insides from any kind of math going on outside. So that means to take that step, the parentheses step, all I have to do is this. I took care of the parentheses, and I got rid of the blue highlighting. That was just to remind us that we couldn't get inside until we take care of everything outside. Okay, well, we've gone all the way through the list. The only thing left to do is to loop back around and start at the beginning and keep operating, because we're not quite done yet. All right, ready to start again, and I've written this on a separate line just because I think that makes it just a smidge easier. Okay, first step, subtraction. Well, is there anything, the variable in question is v sub s. Is there anything being subtracted from it? No. Don't let this negative sign confuse you. Think of that as plus negative, a negative 1 in front of the v sub s, or multiplied by it. So there's something being added to but not subtracted. So I move on to addition. Is the variable in question v sub s? Is there anything being added to it? Why, yes, there is. This term, v sub l squared. So to get rid of it, I must do the opposite operation. I'm going to subtract v sub l squared from both sides. On the right, I have v sub l squared minus v sub s squared minus v sub l squared. Well, this positive v sub l minus v sub l, I'm sorry, I should have said positive v sub l squared minus v sub l squared means it goes away on the right. And on the left, I subtracted v sub l squared from both sides, and I get this on the left. The reason I'm kind of belaboring this point is there were some folks that on the test, they thought that subtracting v sub l squared from both sides didn't look like this, but looked like this. And that's not the same thing. What you've done there is you've subtracted v sub l squared over t from the left side. So that is not the same as this. And don't be fooled into thinking it is. Okay, so that means on the right we clean up to look like this. And on the left we don't have to do anything. There's no cleanup to be done there. Okay, I am done with addition or subtraction and addition. Variable in question, v sub s, is there anything being divided by it? No, there's not. Moving on to multiplication. Is there anything being multiplied by it? Well, some students would say no, but I would say yes. I would say it's being multiplied by a negative 1. I'm going to say this negative out here is a negative 1, so I'm going to multiply both sides by negative 1. Now, strictly speaking, you should divide both sides by negative 1. Since it's being multiplied by negative 1, you do the opposite. But with negative 1, you kind of have a shortcut there. Two negatives make a positive. So if I multiply this side by negative 1, that minus side goes away. On the right, I have negative 1 times the stuff we had before. I put it in parentheses so that you would remember that it... there, it all went away. So that you would remember that it was multiplied by that whole thing. Now let me distribute this out just to make sure that it's very obvious. The right side, that negative 1 times this negative makes it a positive. And the left side, this negative 1 makes this first term, the fractional term, a minus. That negative 1 times this negative makes that a positive. Okay, we are finished with multiplication. Next step is exponents. Well, the variable in question is being squared. So what we do to get rid of that is we do the opposite. The opposite of squaring is square rooting. So we take the square root of both sides. Well, on the right, v sub s squared, then square rooted, becomes just v sub s. And on the left, I take everything and I take its square root. And that is the final solution. I have v sub s equal to a bunch of junk. Now, your math teacher may want you to clean this up a little more. The math guys like to have the positive term first, so you just use the commutative law to put v sub l squared first, then plus -2 delta d over delta t. Really doesn't matter to me. Our goal is to get this variable by itself and nothing else. So I don't care, as long as it's mathematically equivalent, I don't care what it looks like here on the left. Now, let me add one last thing. Some students think that they can replace this with a more simplified version, a version that looks like this. You've taken the v sub l squared in the square root and pulled it out. See, the square root stops right there. Now, a lot of students did that, but I want to tell you that that is not good math. So there, you can't do it that way. Well, let me give you an example. A good way to prove that what you're trying to do is not legitimate is to use some numbers in there, and I'm going to use the following numbers. I'm going to replace this with some numbers. Let's say we pick variables for delta d and delta t such that this number came out to -9. And we picked for v sub l a value that was 5, so that you had 5 squared. Well, if you work that out, the 5 squared becomes 25, and the -9, you got 25 minus 9, you have the square root of 16, which means the right would be equal to 4. Okay, and that's a true statement. So let's do the same thing with this other rendition. I'm going to take this, and I'm going to say that's equal to -9. Get rid of my double lines here because that's a little confusing. And v sub l is now 5. Well, you have an issue with this negative here. You're trying to take the square root of a negative number, and that's a problem. But in addition to that, I've got, substituting those variables, if this was good math, this last one here, then this should end up being true, and 5 plus some weird number, maybe some would argue undefined, is not going to equal 4. So I said all that to say you can't pull it out of the radical like that. It may seem like you can, but you can't. Okay, let's break the video. I'll come back with another one here. It should just follow this one that has a few more samples, examples that I do, and some for you to do.